Okay, we're going. We're started now. Gonna have to trim that piece out. Okay, here we go. Here's what we know. This is nice. I think this is a good way to wind down the course. Okay, and like I said this morning, like the nice thing about doing it in such a packed time frame is like we did this 4 weeks ago, not 4 months ago. It's still in there somewhere, right? Okay, when it comes to the exam too. So we got parallel and perpendicular lines. We dealt with parallel lines. That was like how many solutions does a particular system of lines have. We've done that. We didn't deal with what perpendicular lines were. Okay, you might know what the word perpendicular means. In terms of an equation, you don't, which I'll show you. It's kind of an interesting thing. Okay, so here's what we know about parallel and perpendicular lines. Okay, parallel looks like this in the first picture. We've seen those before. There's no solution. They have different y-intercepts, but the same slope, right? So they never cross. That's nice. Then we've got, in the second picture, we have an example of a perpendicular system of lines or equations, okay? That's where the lines meet. The word perpendicular means where the lines meet at a 90-degree angle. Okay? And then the third one, they're just a horizontal and vertical line, so they obviously meet, oops, I don't even know what I'm doing there, at 90 degrees. Okay, so they're also perpendicular. Okay? Any questions? That's what the word perpendicular means, okay? So, let's come down here and we'll take a look at these equations in the boxes, okay? What is the slope of this first equation? Okay, good. So the m is -2 from y equals mx plus b. Okay, now let's just go horizontally for a sec. We'll just go work horizontally and we'll come back to the perpendicular piece at the bottom in a sec, because we'll just refamiliarize ourselves with what's going on here. Okay, how would I rearrange? I can't read the slope off of this equation the way it stands right now, right? The only way I can read the slope is if it looks like this. Y equals mx plus b. So you better try and make it look like that. So let's do that first. I think this was a multiple choice question on your test for lines, right? It's just taking something that looks like this and switching it. So I need it in y equals mx plus b. So the first thing I'm going to do is just throw the 4 over. And I'm going to get 3x minus 8y is equal to 4. Then I'm going to bring the 3x over. And I'm going to get negative 3x plus 4. 8y is equal to that. Sorry, it's a mess. Oh, okay, you want to do that? That's fine. Reddit, that's a good point. Okay, one sec. Reddit made it a lot easier. You guys want to do what's easiest. I don't know. I'm in the, like, I don't know visually, like I just move things from left to right. I don't know why. That's just my habit, I guess. But Red is right. We could take the -8 and move it over. Right from the beginning, right? So let's do that instead. That seems to be less work. Then to get y by itself, I just divide everything by 8, right? So what's the slope here? Right, so this again, this will turn into 3 over 8x minus 1/2 is equal to y. Okay, nothing crazy going on there. But what's the slope of this new equation? Not new equation, but just written differently. What's the slope? So whatever the number is in front of x, right? M. So in this question, m is equal to 3 over 8. Does anybody disagree? What you're going to find is slope's going to come back big time. in this unit. Which makes sense because we're dealing with lines. Right. Now, y equals 5 is what? That's the question. Is it this or is it this? Okay, we all know it's horizontal subconsciously because we said what? When we were doing parabolas and we found the axis of symmetry, axes of symmetry went up and down, right? They split things in half. And we always said that the axis of symmetry was x equals something, a number, x equals. X equals goes with vertical lines. Y equals goes with horizontal lines. So if I graph y equals 5 on the grid up top here, I'll do it in red so you can see it. Here's y equals 5 on the axis, but then every y value has a value of 5. I could pick any point along that line. -10, 5. I could pick 4 or 5. That's 5, 5. Doesn't matter what point I pick along that line. The y value is always 5. That's how I know that this is a horizontal line. Now, my next question is what's the slope of a horizontal line? What does slope dude say? 0 fun. 0 fun. Right? So the slope with this one, 0.
So it's 0 because it doesn't give you another number?
What's the rise over run? If I gave you those 2 points, you could tell me what the slope is between these 2 points. It's rise over run. What's the run?
Oh no, so it, 0.
Rise over run. Let's do it. That's going to be rise is y2 minus y1 over x2 minus x1. So let's plug in the numbers. y2 is going to be 5 minus 5 over 5 minus -10. So I get 0 over something, 15. So it's 0. That's where this comes from. That's just the proof, right? You can always think back to slope dude and like this is 0 fun. If it's a horizontal line, it's 0 fun. Slope 0. Okay? Now, here comes the new part. We need to find out the slope of the perpendicular line. Let's just for fun take a look at the one in the middle. Can we figure out the slope of this line here, please? Let's do the red. I'll highlight in red. I think this is an effective way to do this. Let's just take a minute, figure out the slope of that line, the red one. So let's just find 2 points. There's one where it goes through the grid nicely. Okay. That's going to be -8 and -8. And then go find another point that goes through the grid nicely. Doesn't matter. You could pick
-4 and -5.
yeah, right here. Okay, let's find the slope between those two points. I know we're running out of room here. This is a good exercise though, trust me. So let's find the slope. So it's rise over run. Which is going to be rise is the y value, so -4 minus -8 divided by -5 minus -8. That's going to equal 4 over -5 plus 8 is 3. Is that right? The other thing you guys could do without actually doing the proof, if you want. What's the rise?
3. Or, sorry. Yeah, you're not from.
Yes.
Why you're at 4?
Because the math said it was 4 over 3. What happened?
Did you switch them up? Yeah, because you're supposed
Oh,
to
I
be-
did.
Use the right line.
Silly me. Silly me. We don't have to do it that way. You guys can go, okay, well, let's just look here. I'll do this in purple. I know it's getting crowded here. You don't need to do it the numbers wise. We picked the nice numbers for a reason, right? I just want to show you, we're going to use that proof over and over and over again, right? The slope, the way they calculate slope, we're going to continue to use that. But we can actually, if you guys look here, we can actually count the rise over the run. It's 3 over 4. Now, I promise I know this is all a little bit jumbly. I'm doing this off the fly because it's something that I think is worth it. Let's go back now and find the slope of this one here, the green one. Is anybody red-green colorblind? Sorry. Here, I'll pick a different color. I guess red-blue is also another one, isn't it?
And I feel like
You can see the shading anyway. It doesn't really matter.
differentiate them.
Yeah. Okay. Here's what I think is interesting about perpendicular lines and what you should think is perpendicular about lines too, or interesting. Let's go find 2 points on here too. There's one. And then let's go, does this one look good, Retta?
I did, what's it called? Negative, sorry, 0, negative 1.
Okay, yeah, that's the one I picked too. Okay. Let's count the rise over run. 1, 2, 3, 4, 5, 6 over. That's the rise. 6 over. 1, 2, 3, 4. Oh, it's not working, Retta.
Like, wow.
I don't know. Does that work?
6 over 5?
This sucks. This
I
isn't working like I wanted. I didn't make this. It's unfortunate.
I know what you're trying to get at, just to show something. I don't know. Yeah, because I also got, when I did it, I got 5 over 4.
Oh, this sucks. Okay. It's ruined. I'm just gonna tell you now. That's really unfortunate. I was hoping that was gonna work. Okay. Here's the slope of the perpendicular line, okay? It's always what we call the negative reciprocal. Okay? So you could put underneath here is what we call a negative reciprocal. Okay? And basically what that means, a reciprocal means the opposite. Okay? So the opposite of, and opposite in terms of fractions, the opposite of 2, you can always write the 2 over 1, right? If I rewrote this, you guys can always write this like 2 over 1, right? Or negative 2 over 1. Reciprocal means you're going to flip the fraction. So it's 1 over 2. But then you also have to, it's the negative reciprocal, right? So you're going to have to do a negative of a negative, which turns it to m equals 1/2. Negative reciprocal. I was hoping that the graph was going to work out nicely for us, that we could see that the answer for the blue line should have been 3 over 4. Negative 3 over 4. But it didn't work out that way.
We learned this last year anyways.
Did you?
Yeah.
Okay.
When I was years old, we used to say a that's negative e, which is just the same thing as negative reciprocal.
Okay. There you go. Maybe you guys already know this. I don't know.
Yeah.
Maybe there's a slight difference in the French curriculum. Maybe there's a slight difference in the French curriculum. Say again?
I learned this in the English one.
Oh, okay. All right. Let's review. Sorry, you guys. I was trying to make it a surprise to you and have it a nice laid out, and it didn't work. But you already knew it. So it's all good. This is nice. We can just go through this now. So m equals what for the next one? For the slope of the perpendicular line. Negative 8 over 3. I suppose I could have just done this and it would have made sense. Perfect sense. I was just trying to surprise you.
Thank you for listening to that.
Yes. As if you haven't wasted any of mine.
So you just like flip it and then
Flip it and make it negative. That's all this means. In layman's terms, flip it, make it negative. That's how you find the slope of the perpendicular. Okay, how do you flip 0? It's undefined. What does undefined go with? X what? A vertical line. So if the line, if I flip 0, like this is technically 0 over 1, right? I've already said that. If I go m equals negative 1 over 0, I break math. I'm not allowed to divide by 0, but it means something. It means that this is a vertical line. Right? Vertical lines don't have a slope. They're undefined, as Slope Dude calls it.
Wait, but since it's negative, wouldn't you have to flip the vertical line over?
Yes. What? I don't know. I guess. Okay. So that's how we know if you have a horizontal line, when you take the negative reciprocal of the slope, 0, it becomes a vertical line, because vertical lines are perpendicular to horizontal lines. Like magic. Okay.
so we can still say undefined.
Yeah, you can say undefined. You could run undefined in there if you want. Okay, sorry, that was a mess on top. I was trying to do some things on the fly that I thought would add to the lesson, but it didn't work. Those lines aren't great, I guess. Not plotted well. Okay. So, to create an equation, you recall, you need 2 pieces of information. Equation of a line, I would say. You're going to need slope. And 1 point. Or you could have 2 points. Either will do.
The
Rem-
y-intercept irrelevant?
You don't, that would just be underneath the 1 point category. Your y-intercept could be the 1 point that you need.
Can you write M and B for the top one?
M and B, yeah. That's what it is. B is just a point, right? The y-intercept is just a point. That would classify you in the slope in 1 point category. If you have 2 points, you can just find the slope like I showed you up top already, okay? And then we can always have 2 different ways to write the equation of a line. We've seen them both already. It's ax plus by plus c equals 0. That's what we call standard form. You guys know that. Okay. And you can also have the one that's most useful, probably, y equals mx plus b, which we call slope intercept form. It's kind of a nice lesson. Just bring us back, like deja vu. Okay. So here's what we're gonna do, okay? I think this next point, I was confused with this next point, but I think it belongs on the next page with the 2 questions that we're gonna do, okay? Just somehow the spacing didn't work out. Okay, so there are 2 different ways to create an equation of a line. We're gonna see them. So turn the page over. I suppose there's a whole bunch of different ways, but I think this is starting to target like 2 points, slope and 2 points, sort of thing, or slope and 1 point. Just trying to target that from the first page. Okay, so we're gonna try and determine the equation. Okay, this should look relatively easy relative to the quadratic ones. Determine the equation of a line in standard form. which is parallel to y equals 3/4 x plus 7, and goes through the point -12, 3. So we need a line that's parallel. Remember, we're up here under, like, that looks like this. So what are we saying with parallel lines? They have what? The same what? Same slope, but different what? Are you two paying attention over there? Obviously not. It's not my exam on Wednesday. Okay. Same slope, different y-intercepts. That's the fundamental, like, that's what you're going to do here with this question, right? So I'm trying to create an equation that has the same slope but has a different y-intercept. So I'm just going to rewrite the fact. Here's the line that I'm trying to create. It has the same slope as this one. It's told me that. It's parallel, right? So y is going to equal 3/4 x plus b because it's parallel. But it has a different y-intercept. Is that okay with everybody? That's fundamentally what parallel lines are. Okay, we've already seen that. Now, you also already know how to do the next part. You have an x, you have a y, plug them in, solve for b. Let's do that. Now you know what the y-intercept of this new line is, right? So 3 equals 3/4 times -12 plus b. Who's freaking out right now? We've already done this, yeah. I just making sure everybody's basis of math is okay. When I multiply fractions, what do I get? 3 times -12 divided by 4. You can choose to multiply the 3 in and then divide everything by 4. You will arrive at -3. Or you can choose right off the top. I recognize that -12 can be divided by 4. It goes 3 times. So I get 3 times -3. Tricks. Okay? It's just one less, like, you want to avoid typing in your calculator as much as you can. It's just slow. It's inconvenient. And sometimes you type things into your calculator wrong when you can do mental math like this, right? You just got to manipulate what you see. Okay? Is that okay? That's where that came from. So I'm going to get 3 equals -9 plus b. 3 plus 9 equals b. So b equals 12. Now, I can rewrite the equation. Y equals 3/4 x plus 12. Right? And it wants it in standard form, which means I got to make it look like this one from the other side. ax plus by plus c. ax plus by plus c equals 0. That's what I need to make it look like. So let's do that. I'm just going to start bringing stuff over. -3/4 x here. Unconventional. Less work. Let's do this side. We'll bring the y over. As Retta says. I don't know. I'm weird. That's weird. I do that.
I don't know.
It's a weird subconscious thing that I do. Because it's less work.
I just feel like usually if there's one thing here and 2 things here, just bring the one thing instead of bringing the 2.
Right. There are some like one other thing here. Okay. Up until this point, I've been kind of okay with this being here like this. There are some fundamental rules with A, like the way this looks. Okay, I'll write the rules here. A can't be negative. No fractions.
So you put a decimal in it?
No, no decimals either.
Oh, so oh yeah, yeah, yeah.
Okay, and they always have to follow the order too. I don't know if you guys saw this or not. I forgot about this, if I'm speaking honestly. Okay, then this is just a formality thing, right? It's just a form. It has to follow a form. It has to follow some rules, right? So no fractions allowed isn't the biggest thing in the world. You guys know how to get rid of fractions. If I multiply this whole thing by 4, it'll get rid of the fraction. Right? 0 equals 3x minus 4y. 12 and 4 should be 48. Okay. Nothing crazy there, actually. It's not bad. Everybody freaking out? No?
Why is it plus 48?
Because I have to multiply the 4 into all 3. And the 0. Technically. But the 0 times 4 is still 0. Okay? That's your final answer. It's a good one. We already know how to do that. There's just a couple little extra formality things we tack on the end. Okay? Okay, let's do the last one. Last one's interesting. These are great thinking questions, and they're great at like pulling concepts together, and that's what that assignment's going to do for you. Okay.
I think it was smart keeping kind of like geometry till the end, because now we have all like, our tools to be able to like find midpoint or find slope. Now it's just like using it into like a question where you actually have to think.
Yeah. Well, I mean, I'm not going to say I did that intentionally. Most of this stuff, like, it's not that you're going to do away with lines, but there's just some things in grade 10 that are more important than others in terms of the bigger picture of the math pyramid. You know what I mean? You need to know factoring. You need to know your quadratics. You need to know trig. Right? So the thinking involved from analytic geometry is the important piece. That's why I think we kind of do it. It's a medium in which to promote thinking. You know what I mean? So I guess at the end, yeah, you're right? Because these questions now look easier than your quadratic questions where you're coming up with the equations of the quadratic, right? But I can throw some more layers in here now. That's not necessarily the challenge, you know? So we want to determine the equation of the line in standard form. Okay, so nothing's changed from the last question. Here's what changes. The slope has to be perpendicular to this line, okay? But it has the same x-intercept as this one. Okay, so they've given you 2 pieces of information here. Okay, I know, because I've told you, well, I know you know, because I've told you, the word perpendicular to this, I'm trying to rewrite a line here. So y equals, I'm going to take the same approach as the last one. I'm trying to rewrite like y equals mx plus b, basically. I'm trying to create a line. And then once I get this line, I'll switch it to standard form at the end, okay? This is like the series of steps that we're gonna follow, right? So it told me the slope was perpendicular to this one. So the slope is 3 in this question. So the perpendicular slope to that one is what? Flip it, make it negative. So we'll denote that as being m perpendicular. Is that okay? So the little new, there you go, Coco, it's like MP. MP for midpoint, M perpendicular.
Is that like an upside down T or something?
Upside down, yeah, it'd be like a little 90-degree angle in the corner, is what it's kind of trying to denote, you know? Like there'd be a 90 degrees there, basically. M perpendicular, that's the perpendicular slope of that line. Okay, it's negative 1/3. Flip it, make it negative. If it's already negative, it becomes positive. Does that make sense? Okay, so now I can put that in as a slope. Because I'm just trying to build an equation based on the information that it tells me. So y equals negative 1/3 x plus b. Okay, half of the question done. Here's the next piece. We keep reading. It tells us that it has the same x-intercept as this. How do I find the x-intercept from that equation? I'll do this over here. How did I find x-intercepts when we were dealing with parabolas? If I drew a parabola here, how did I find the x-intercepts? I did something specific. I know we had a few methods. We had things like factoring. We had quad equation. Things like that, right? But there was something fundamental that we were doing in all of them. It did not matter what method we used. We always did something equals the equation. What was the something on this side? What's the number? Well, it looks like an O. Let me ask it a different way. We always got what? We always got two x values here, right? What are the y values that correspond with x values that cross the x-axis? Or points that cross the x-axis? Like if I were to write the point here, doesn't matter what the number is, what am I going to write here? It's the number and 0, right? That's one x-intercept. And the other one here is going to be number and a 0. This is x and this is y. Right? What am I plugging in for y is my question. In this question, in this equation. It fundamentally does not change. It's an x-intercept. It just means that the line is coming through here and it crosses here. What am I plugging in? 0. Okay, so this is y. If I plug in 0 for y, it's going to tell me where it crosses the x-axis. So let's do that. Okay. I'm just going to keep trying to make connections with you guys, because I'm just going to try and put the whole picture together. That's an example of it. Okay. There's fundamental skills that we have done in other parts of the course that are the same things, independent of what function we're dealing with, right? So I'm going to plug in 0 into this equation. It's going to, and then solve for x. Okay. Remember, this is like y. I'm plugging in y. So now I'm going to go 4x times 0. 0 times anything, 0. 4x plus 12 equals 0. 4x is equal to negative 12. 4x, divide both sides by 4. X equals negative 3. My x-intercept, negative 3, 0. It's 0 because I plugged in 0. Now what? It told me that the lines had the same x-intercept. We just found what the x-intercept was. I now have an x and a y to plug in to this equation to solve for b. probably did a little bit more talking than I need to here, right? But the point is, we're trying to make the connections with everything that we've done. Because we're at that stage of the course where we're gonna have to start making connections. Go.
So then, you already did it up here, but just to, I don't know, I kinda wanna see it again. So what did you do to get those two things in brackets just to turn into one?
Two things in the brackets to get to one. What do you? Oh, the math piece. This thing?
Yeah.
I'm just doing math. So you're just gonna do top times top and bottom times bottom. What is that?
Oh, so it's -3/3.
Negative 3 over 3. Actually, be negative 3 over negative 3. Because there's two negatives.
So that also makes it.
That makes it. Oh, did I? Oh no. That makes it positive 1. Right? This here, I'll highlight it so everybody can see. That turns to the 1. Just multiplying fractions. Maybe we need to do more of that. We'll just do more work with fractions. Oh, I'm gonna do some work with some fractions. It's gonna be fun actually. Fractions and quadratics. So it's gonna be a great time. Those are like the two worst words that I could possibly say to all of you right now.
Like have we not already seen that?
No. I mean, I gave you a prank quiz on it, but
So that's not the same, that wasn't a quadratic.
no, it wasn't. It's not really going to be a quadratic, but anyway, we'll talk about that later. Is everybody okay with that? How we got the b value to be 1? Now you can rewrite the equation. Negative 1/3 x minus 1. Rewrite it into ax plus bx, or ax plus by plus c equals 0. So we're just going to bring the y over. It's 0 equals negative 1/3 x minus y minus 1. I'm going to have to multiply the whole thing by negative 3. And we get 0 equals x plus 3y plus 3. All I did was multiply this into all three pieces. You can see how it's easy to get bogged down here, right? There's only 2-3 steps there, but there's a lot of thinking going on there and pulling on concepts, x-intercepts, perpendicular slopes, standard versus y-intercept form. All sorts of little concepts. This is what this is good for.
How many points is that question?
I don't know, 5 or 6 probably. Your assignment is 1 page question, 22 mark.
Is it something like this?
It's along these lines. I'm just building you towards the assignment right now.
Is this stuff gonna be on the exam too?
Yeah, that'll be on the exam. Midpoints finding midpoints, find the equation of a line, perpendiculars, parallel, stuff like that.
So like, basically the assignment's gonna be something like this, just like with a
More.
bunch more steps.
It's very sequential. It's gonna take you some time to step your way through it. If I were you, I'd come up with like a game plan on the side of like what you need to do. Just put some thought into it and then go through and do it. That's what I would do.
And how long do you have to do it?
You can hand it to me on Wednesday. I don't care. I'll give it to you today before you leave. You can hand it to me on Wednesday at the exam. I don't care.
But it's not like the same as like our pattern, like
No, it's
assignment.
different from the pattern assignment.
Like this one, you're giving us something and then you can do that. The other one, we come up with our own
Yeah.
equation.
I'll do the type up for that today too.
You do what?
I'll type it up, the assignment, and give it to you today, hopefully. You might not get your test back till tomorrow. I think the pressing thing, I want to give you the time to work on the assignment.
What is this trying to do? Not the patterning one?
We can make it do at the exam. I don't care. You guys can hand it to me anytime you want. It'd be nice if you did it early for me so that I don't have to mark 2 assignments and then an exam.
Why don't you just make the due date early?
I can make it due Tuesday, but I don't want to stress anybody out. I'd rather take on the stress for myself. I know.